Okay, today we're going to learn about the associative property of addition. Associative. This should be page 14 in your notebook. Our learning target today is to identify and apply the associative property of addition. And a great way of thinking about associative is the word group. So if you think about what group do you associate with, nerds, turds, or crazy birds, right? The words group and associate are synonyms for each other, just like the words commute and move. So associate is a great way of thinking about the word, or group is a great way of thinking about the word associate, how you group something or what group you're in. APA is the way you can abbreviate this property in Schoology, and the associative property of addition states that when adding more than two terms, there's that word group, grouping of the terms does not change the sum. So when adding two or more terms, the grouping, or the way you group them, does not change the sum. And here's the math definition. We've got A plus B, right, plus C is the exact same thing as B plus C and then plus A. So the way we group these will not have any impact on our answer. And that's true with any real number. So I've just selected these arbitrarily. And we've got, let's see, if we group the 3 plus 7, that's the same exact thing as grouping the 7 plus 2. It just changes the order which we perform the operations. So here, what we're going to do first is we're going to add the 3 and the 7, we're going to get 10, and then we'll add the 2 to the 10, and we'll get 12. Whereas here, order of operations tells us we need to add these two first, we get 9, then we add the 3 in, and we get 3 plus 9 is 12. So we get the same exact thing. So if we see in that algebraic example, we can go ahead and group 5x plus 3y plus 8. So grouping these three terms together is the same exact thing as if we just grouped these two terms together. So these two things, these two expressions are equivalent to each other. They're the same. We're just grouping, we're adding these three first, whereas here we're just adding these two first. Eventually everything is going to get added. So associative property is grouping. Now what happens with subtraction? So with subtraction it can be quite tricky. So I'll give you a couple examples. Good example and bad example. So we have let's say blue or purple, not sure what color this is, I'm colorblind. This is good example, and I'll give you bad example. Bad example. So good example would be turn the subtraction into addition. So if we turn this into addition, we get 5 plus a negative 3 plus 1. And now we can say, okay, this is the same exact thing, adding these from left to right is the same exact thing as adding, using the associative property of addition. We can say this is the same exact thing as adding 5 plus negative 3 plus 1. So adding the negative 3 plus 1 first according to the order of operations, right? And when we do that, what we get here is we get negative 3 plus 1 is negative 2 plus 5. So 5 plus a negative 2, and that simplifies to a positive 3. So with subtraction, very important that we have the addition sign on the outside of the parentheses. So here's the incorrect example. Let's say we didn't do that. Let's say we had 5 minus 3 plus 1. So you can see here, we left the subtraction sign outside. And for those of you that know how to distribute, right, if we were to distribute this back in, now this 1 all of a sudden is a negative 1, and it was never a negative 1. We've changed the term from a positive to a negative, which you can't do. But you'll see this as I simplify it. We have 3 plus 1 is 4, and then we have 5 minus 4. 5 minus 4, that equals a positive 1. So you can see we've already got a different answer, and that's why. We're not subtracting this 1, we're actually adding it, and leaving the negative on the outside makes it subtraction. Another non-example would be if we just didn't include the negative on the outside, we just left it in the inside. So this is what we see most of the time. If we had 5 parenthesis negative 3 plus 1. You can see here that inside the parentheses it's negative 3 plus 1, which is correct. But as soon as I simplify this, right, it becomes multiplication. The 5 is now being multiplied, so this is already, this is another non-example. Turning something that was being subtracted into multiplication is not with the property. So just to talk about the difference between the two properties. The commutative property changes the physical order terms are added by moving the sequence of terms around. So the sequence here is 1 plus 2 plus 3, and the commutative property says we can change the order that they're added by just moving them around. So we can say this is the same exact thing as 2 plus 3 plus 1, right? Where from left to right we would add 2 plus 3 and we get 5 plus 1, which is 6. So we get 6, right? Whereas the associative property changes the math order. So it's changing the order that terms are added, but it's the math order, not the physical, by adding or regrouping the order of operations in the way that they're performed. So we're using parentheses to do this. So if we had the expression here, 1 plus 2 plus 3, where these two were added first, let's say we wanted to add the 2 and the 3 first, and then the 1, instead of rearranging or moving terms around with the commutative property, we can just say, okay, let's just add the 2 and the 3 and leave them where they are. So we'll just do 1 plus 2 plus 3, whereas now we're moving the parentheses, not the physical location of the terms themselves, where this is 5, and then 1 plus 5 is 6. So the difference is just using the parentheses to change the order versus changing the physical order. Real quickly, let's just try to add all of these numbers together using both properties. And a very easy way would be to commute first these two numbers, or these two terms, and we would get 53 plus 47 plus 18 plus 82, and then to associate these two numbers together, where we now have 53 plus 47, we know that adds up to 100, and we know that 18 plus 82 adds up to 100, and so we know this total thing is 200. So this is just a way of kind of rearranging terms to make it easier to add. Example number 1. Provide the justification for rewriting the expression. So here we have the expression negative 2y plus 8 plus x, and the new expression is negative 2y plus 8x plus 8 plus x. So the location of the terms has not changed. The order that they appear has not changed. However, the order that we perform them, or the way that they're grouped, has, right? We've grouped now, instead of adding from left to right, we're going to add these two terms first, and then we'll add the term that appears first. So what allows us to group them this way? Commutative property. Nope, sorry, that's not the commutative property. Move. The associative property of addition. Example number 2. So here we're also filling in for the expression as well as the justification. Important note is that you cannot overlap groups. So you can see here, and I'm going to use colors to do this because it's best, we've got a large set of parentheses around the C plus a negative D plus E. We've got this large set. And then within that large set, we've got another little group where we've grouped the negative D plus the E. So we've got these two groups. Now I'm going to come down here and I'm going to show you what I mean by saying when I say this. Not only do we have to shift the smaller group of parentheses around the C minus D, we also have to shift the larger set. And there's only one way to do this without overlapping the groups. And when I say overlapping, what I mean is this. Let's say that we shifted the large set of parentheses without shifting the small set. So the small set incorporates the negative D plus E, right? But if we shift this large set the way it needs to be around the Y plus C minus D, then what ends up happening is we have overlapping parentheses. Now we've got overlapping parentheses, and you cannot have overlapping parentheses. So first you have to figure out what set are you able to logistically move without causing there to be an overlap. And the answer is the red, the smaller set. We can shift these to incorporate the C plus minus D. So that's exactly what we're going to do. We're going to say that this expression is the same as big set, little set, C plus minus D is the same thing as subtraction plus E. So you can see we've shifted the parentheses. So now that the little set is around the C minus d, or plus a negative d, same thing, and the big set still remains around the three terms that originally incorporated. Now that we've shifted the little set, we can shift the big set without overlapping the parentheses. Now we can shift the big set without overlapping the little set. So that's what I mean by overlapping groups. And the last step, or the justification for that, we already know is APA. Two more examples. Example number 5. Okay, so here we now have a larger proof, and in addition to that, we're now combining multiple properties. So now we've got both the commutative property of addition in play and the associative property. So the first step is to identify the number of terms, the original amount. So if we look at our given expression, we've got one term, we've got two terms, we've got three terms, we've got four terms, and they're numeric expressions, so they're only numbers. So I encourage you to kind of simplify as you go through this to see if every time they yield the same amount. Because if they don't, then that means that we've used the property wrong or rewrote the expression wrong. So we have to figure out is, what did they do from this first expression to this second expression? So first we're going to look at the order. Look at the order that they come in, the physical order. That's the first thing that we're going to try to identify. Did the order change? Because if the order changes, then we know that it's commutative property of addition. So we have 1, that order hasn't changed, and now you can already see the order of the second term has changed, and the order of the third term has changed. So we know that it is the commutative property of association, because what they've done is they've commuted this positive 3 in front of this negative 2, and the negative 2 behind the positive 3. And now we've got to figure out from there what was the next thing that they did to rewrite the expression. So the order has not changed. You can see here we've got a positive 1 that comes first, then we've got a positive 3 that comes after it, then we've got a negative 2 that comes after that, and then a negative 4. So the order has not changed. So the second step to see what they've done is to identify if they've regrouped. Have they regrouped something? And you can see that they have because they used parentheses. So if they're regrouping something and not changing the order, the property is associative property of addition, and we know that they're grouping things that are being added. Now the question becomes, okay, they've regrouped. Well, we've got to fill in this blank expression. So we've got to identify what are the changes from this expression to this expression, and there should be 2, right? There should be one change right here that we've got to fill in, and then one change from here to here that we've got to fill in the justification for. So the first change, if we look at the order, there's one term, there's two terms, and now there's three terms. Because they regrouped, the parentheses now count as one term. So we've got 3 terms now. Down here, we have 2 terms. So since there's 2 terms, 3 terms to 2 terms, that means that they've definitely used the associative property, and you can see that with the parentheses, right? And then within the second term, you can see the order has changed. We had 1, 3, negative 2, negative 4. Now we've got 1, negative 4, 3, negative 2. So the order has changed. And this property is saying we changed the order. We commuted the terms that were being added. So we've got to figure out, okay, how can we write this correctly? And we know that the terms that changed location were the parentheses and the negative 4. So the parentheses got commuted behind the negative 4. You can see that right here. And then it looks like they regrouped. So to write that correctly, it would be 1 plus, actually we don't need the plus. The reason we don't need the plus is we're commuting something that has a negative, so we can say 1 minus 4 parentheses, or plus parentheses 3 minus 2. Now it's correct, and then our last step is they regrouped, they added parentheses, and that would be a